Well, hot diggity dang, this is the last video you have to watch this school year. Let's get started. Number 10, change r equals 5 over 1 minus cosine theta to a rectangular equation. So let's go ahead and rewrite this as r equals 5 over 1 minus cosine theta. Haven't done anything at all to it, just rewrote it. I'm going to multiply by 1 minus cosine theta on both sides, and I'm going to put parentheses because we're talking about multiplying two terms. This cancels, and then I'm left with equals 5 on that side. I'm going to distribute through my r, so that gives me r minus r cosine theta. And hopefully you remember that r can be rewritten as the square root of x squared plus y squared. And minus r cosine theta, or just r cosine theta, can be written as x. I just rewrote the negative sign, or the subtraction. I'm going to add x to both sides. Okay, cancels over here, and I'm left with the square root of x squared plus y squared equals x plus 5, or 5 plus x is fine as well. And I'm going to go ahead and I'm going to square both sides. Squaring the square root, they cancel each other out, they're inverses, and I'm left with x squared plus y squared. And then I've got to FOIL this out, or do box method. So just as a reminder, that's x plus 5 times x plus 5. That's x times x is x squared. X times 5 is 5x. 5 times x is 5x. And 5 times 5 is 25. Or you could do box method, whatever works for you. So this is going to be x squared plus the 5x's become a 10x. Plus 25. I want to solve for y, so I'm going to go ahead and subtract x squared from both sides. And that gives me a y squared equals, this disappears as well, or cancels out, 10x plus 25. Then we need to square root both sides, and I'm just left with y equals, and then a plus or minus the square root of 10x plus 25. That's it. Okay, number 11. If a vector v is equal to I minus 2j and vector w is negative 4i plus 6j, find the magnitude of the vector 3v plus 2w. Leave your answer in simplest radical form. Okay, well, first thing we're going to do is we need 3v. So I'm just going to take v and multiply it by 3. So that's going to be 3i minus 6j. Then I need to double w. Woo. So 2 times w, so I need to double this. So that's going to give me 2w equals a negative 8i, and then double 6j is 12j. So I'm just timesing everything there by 2. And the problem asked me to actually add these two things, so I'm just going to put a plus here and a plus here. So that's a 3v plus 2w is equal to a negative 5i plus a 6j. Well, what is that? A negative 5i is negative 5 times 1, 0, plus 6 times 0, 1. Well, that's going to become a negative 5, 0, and a 0, 6, which does become a negative 5 and a 6, because I'm just adding negative 5 and 0 to get there, and 0 and 6 to get here. Of course, magnitude means the length, and the length of that is just going to be the Pythagorean theorem of the two legs of the right triangle, our horizontal components. So I just have to take those two numbers and plug them in, and I get 25 plus 36, and that's going to give me 61, or the square root of 61. That's it for that, folks. All right, for this one here, we have to prove that this is an identity, and to do that we have to work with the more difficult side of the equation to get it to look like this. So what I'm going to do first is I'm going to rewrite cosecant x as 1 over sine, and I can do that by having 2 minus cosine squared x all over sine x, right? Because cosecant is 1 over sine, so that's why the sine goes into the denominator. All right, so now next thing is I need to take cosine square x and substitute in. So for example, I know sine squared x plus cosine squared x equals 1. So subtracting sine squared from both sides, I'm left with a cosine squared x equals 1 minus sine squared x. So I'm going to go ahead and substitute in this in for cosine squared. So that's going to be equal to 2 minus, parentheses, 1 minus sine squared x over sine x. All right, now I just need to distribute that negative through. So I'm left with 2 minus 1, and then it becomes a plus sine squared x over sine x. Okay. And then what is 2 minus 1? Well, that's just going to be simply 2 minus 1 is just a 1 plus sine squared x all over sine x. All right, now I'm going to go back up here. I'm going to keep going. And I'm going to rewrite this as two fractions. I'm going to write it as 1 over sine x and then plus a sine squared x over sine x. Well, what is sine squared x? That's simply what? That's going to be just sine x times sine x. You don't need to do this part if you see it already over that. So it's going to give me this over this. So that gives me 1 over sine x plus sine x. Well, I'm in really good shape. I've got this, right? I've got that 1 over sine x, but I only have a sine x here, and I need a 1 over cosecant x. Well, actually, those are the same exact thing. And the reason I know that is because cosecant x is the reciprocal of sine. We've literally just written the definition, so we know that 1 over cosecant is, and don't put that as part of your answer, but we know that that's 1 over sine, which is the same thing as this, right? All right, so that's it. We've got it done. Your problem on your test looks really similar to this, except it's definitely harder. You wouldn't have to do that last step or know that. All right, so there we go. We got a check mark that that's equal to this right here. All right, last problem. Whoa, it's like magic. Look at all these things that just popped up. Basically what I did here was I read through the problem. I saw that I've got a force 1 of 14 newtons at 60 degrees. So that's force 1, 14 newtons at 60 degrees. I've got 5 newtons at 300 degrees. And then I've got my force 3 is 7 newtons at 100 degrees. And we want to break these down into their x and y, or horizontal and vertical components. And to do that, we're just going to take our newtons and then cosine and then the angle, and that's for the x component. So notice how all the x's have the cosine and all the y's have the sine. So then we just pick up our calculator, making sure that it is in degrees mode. And for this one, I get 7. For this one, I get 12.12. For this one, I get 2.5. For this one, I get negative 4.33. Here, I get negative 1.215, and here I get 6.89. And then to get my F sub x, or just my x force, I'm just going to add up 7 plus 2.5 minus, sorry about that, minus, oh heck no, minus 1.215. And when I add all those up, I do get an x component of 8.285. And then when I add up all my y's, I also get a 14.68. Now I know in class we really did a lot where it didn't end up being in the first quadrant, but on your final exam it's nice and it will end up being in the first quadrant, just like this problem. So what does this look like? Okay, well, we end up with a resulting force vector with an x component of 8.285, so that would be 8.285. And then we have a y force vector of 14.68. And of course, we want to find F sub r, or the resulting force vector. And to do that, we're going to use the Pythagorean theorem, right? It's going to be the square root of F sub x squared plus F sub y squared. And so just plugging right into that, I get 8.285 squared plus 14.68 squared. Those parentheses are really important if you have negatives. And then I get a resulting force vector of 16.86, and that's newtons. Now to find the angle, we're going to do theta equals tan inverse of f sub y over f sub x, or just really it's opposite. Here's my theta right here, opposite over adjacent. So theta in this case is going to be tan inverse of my f sub y, which is my 14.68, or you can think about that as the opposite, and then divided by the adjacent 8.285, which is my f sub x as well. And here I just get a theta of 60.56 degrees. And usually we have to make sure where is what quadrant are we in, subtract from 360 or 180, but in this case we're in the first quadrant. That's just simply going to be the answer. So our final answer is going to be 16.86 newtons at 60.56 degrees, and we should rewrite that at 60.56 degrees. That's it, folks. It's been an absolute pleasure doing videos for you. I hope that you learned. I know it's not the best method, but it's been a real pleasure. Take care.